Today I'm going to show you how to use the properties of logs. Like the properties of exponents, the properties of logs help us to simplify and to solve. At this time, I would like for you to pause the video and complete the exploration to the best of your ability. You will see that in question 1, part A, I want you to evaluate each log separately. 2 to what power is 4? Find that value. 2 to what power is 8? Find that value. Add them together. For part B, I would like for you obviously to multiply those numbers together first, and then think 2 to what power is 32, and then compare the answers you got for A and B and think about what does this mean. I then want you to complete the other questions the same way for this exploration and then come back and watch my video. Welcome back. You should notice that for the first part, you should have gotten 2 plus 3 equaling 5. And then for the second part, you also got 5. Those answers are the same, but what I really wanted you to note is that we have a 4 and an 8, and we multiply them together, and that is allowing us to get the same answer. So I got really wordy over here, but not only did I say the answers are the same, I said that the sum of two logs with the same base, so that's what was given to us in part A, a sum of two logs that had a base of 2, is equivalent to the log of the product of their arguments with that same base of 2. If that doesn't make sense, don't worry. We will address that in the notes today. Now, for the second question here, I asked you to subtract what you got from each of those logs. So after you evaluated 3 to what power is 81, 3 to what power is 9, when you subtracted those answers, you got 2. Now, if you connect A to B, you'll notice that I made a quotient of 81 and 9, and that allowed me to get the same answer. So I put the answers are the same. The difference of two logs with the same base is equivalent to the log of the quotient of their arguments with the same base. And then finally, I had you guys look at question 3, where if you evaluated 4 squared, you would have gotten 16. 2 to what power 16, you got 4. Or if you did part B, you could have done log base 2 of 4 is 2, multiply that with 2 and got a 4 and saw that those answers are the same. Now, what I wanted you to note is that in part A, there was this power on the 4 of 2, but for part B, that power of 2 got moved to the front, and those answers were equivalent. Now, I put a little note where it says Y with a star down here, but if you think about what we talked about in part A, how we can connect this idea of this product that we saw in part B coming from the sum of those two logs, you technically can think about 4 squared in number 3A as 4 times 4. And then if you work backwards, it's really like the sum of log base 2, 4 plus log base 2, 4, which is equal to 2 log base 2, 4s. Now, I know that's a little deep for right now, and as we explore this more, I think you might want to come back to that and really think about this after we complete this note sheet and maybe tomorrow's, why that is in fact true. So today, let's summarize what we just saw in the exploration and then do a little practice with the properties of logs. The first property you guys need to know is what we call the product property. If you ever have a log with a base of whatever number and there is a product in the argument of that log, you can rewrite this as log base b of the first part of that product plus log base b of the second part of that product. The second property is the quotient property that says if you have a log with a base of b and a quotient, you can rewrite that as log base b of the numerator minus log base b of the denominator. And then finally, the power property states that if you have a log with a base of b and an argument of a, and there is a power on the argument, you can move that power to the front, and that is equivalent. So those are the 3 properties that we're going to be using a lot this week, actually the remainder of the week, so you'll be practicing them. So let's look at some examples of what you're going to do. This next page, they are just rewritten, so we don't have to keep scrolling back and forth for you. For the first problem in the set of examples, you are going to see that the directions say write each log expression in expanded form. That means you want as many logs as possible. You're going to use our three different properties. So to start, I see a log base 3, but then I see a product of 5 and x. So you are going to use the product property that says if you have a product, we can rewrite it as the sum of each part of that product. So in other words, this becomes log base 3 of 5 plus log base 3 of x. Done. Moving on to the next question, I notice a quotient. So I am going to use the quotient property. This becomes log base 7 of the numerator value, 6, minus log base 7 of the denominator value, y. And that is your final answer. Technically, I'm going to get technical with this. Because 6 is not a prime number, you can actually think of 6 as 2 times 3. And if you want to keep going, you can expand this even more by saying log base 7, 2 plus log base 7, 3 minus log base 7, y. Notice if I rewrite 6 as a product of 2 and 3, I'm back to what I did for part A, where I'm expanding that product into 2 logs. So technically you can take this and expand it into 2 logs and then rewrite that log base 7y. Now for the final question in this set, you're going to see that there is a power on the log. Whenever you see a power, you can take that power, if it's on the argument, and move it to the front. So this is really 2 times log x. Moving on to the next set you're going to notice are a little bit more involved. For these problems, we are going to be using the properties again and rewriting in expanded form. This first one, though, is tricky because it looks like we don't have any of those 3 properties. But if you remember, the cube root of x can be rewritten as x to the 1/3 power, and then we do have a power here that we can address. We can take that power and move it to the front, so I get 1/3 times log base 2 of x. Moving on to part B. Part B is the trickiest one we've seen yet, because this actually involves all 3 properties. I see a product in the numerator, I see a power on just the x, and then I see a quotient of all 3 terms. Of all 3 of the properties, the only property that is affecting all 3 terms is the quotient, so we have to take care of that first. I'm going to rewrite this as log base 7 of the numerator minus log base 7 of the denominator. Now, I cannot take care of this power of 2 next because it only applies to the x. I need to actually separate the product on this log first. So I'm going to rewrite this first log as log base 7, 4 plus log base 7 x squared minus the log base 7 y. Now, technically 4 can be rewritten as 2 times 2 or 2 squared. So if you want, you can rewrite this as 2 times 2 and expand this one more time. Log base 7, 2 plus log base 7, 2. And then I'll rewrite these next 2 logs. Now, technically, these are like terms. So even though it says in the directions as many logs as possible, commonly we combine our like terms. So I know technically you could write it as more, but we're going to say that that's actually just 2 log base 7, 2. And then for the other 2 logs, we have to move those 2, or I'm sorry, just for the second log, not second, I guess technically the third log. What am I saying? For that third log, we can move that 2 to the front. And that last log I realized didn't have a power, so we can just rewrite it as is. So that would be our final answer for that one. That one is very tricky, and don't you worry, there will be more practice of that so you can make sure you really understand it. Moving on to part C, we have another situation where I see a radical. Right away, I'm going to rewrite that with a power. A to the 1/2 power is the same thing as the square root of A. Once I rewrite that as a power, I see there's two properties here, a product and a power. Because the product affects both logs, or I'm sorry, both the 3 and the A, and the 1/2 only affects the A, I have to take care of the product first. Okay, that 1/2 only applies to the A. Then I can move that 1/2 to the front of only the second log. And that is my final answer. And then finally, the last question in this set, another problem just like the one above, where I have a quotient, a power, and a product. Again, the power here is only affecting the x, so I'm not going to take care of that yet. The product down here is only affecting the 5 and the y. I'm not going to take care of that. I have to take care of the quotient since that affects all three terms. So we're going to rewrite this as log x cubed minus log 5y. Then from there, I can move this 3 to the front since it only applies to that log. And with the second set, I can take care of this product. Now, be careful. There is a minus sign in front of this log. Kind of think about it being like in a parenthesis or bracket. If you expand this log, the minus sign has to apply to every log you expand. So if I expand this into log 5 plus log y, I have to distribute this negative to each of the logs. So I would get this answer of minus log 5 minus log y. In the future, we're going to talk about condensing. And when you condense, if you have more than one log that has a minus sign in front, it's going to go into the denominator together. If you put a plus sign in front of the log y, that would technically become a product and would make it go into the numerator. But since we want both of those in the denominator, they both need to have a minus sign in front.